Hello, welcome to Chapter 6, Homework Questions 35 through 40. Question 35. Charlie's friend is visiting from Texas and asks him, what does a hamburger cost in this town? This caused Charlie to wonder because the price of a hamburger seems to be different at every eatery. Charlie thinks there may be an association between the amount of meat in the patty and the cost of the hamburger. He collected the following data. So a couple things to look at. First, you have your table. Meat in ounces is your independent variable. It's on your x-axis. And then the dependent variable is the cost in terms of dollars. You have the different points already plotted and then the line of fit drawn. So your least square regression line is y equals 0.253 plus 0.735x. So all that information is already given to you. So now we're going to go ahead and answer the questions based on that information. So on question A, it asks, interpret the slope and y-intercept in context. So first off, what is the slope of this line? Well, it's this value. That is the coefficient of x. It is positive, so 0.735 is the slope. And then what does that slope represent? The slope means that for every increase of 1 ounce, and remember that this is over 1, so this is the change of x, and this is the change of y. So the 1 is the change of x. So once again, that for every increase of 1 ounce, which is your x, in the patty size, you can expect to see a price increase of 0.735, or since it's money in dollars, 0.74 if we want to round. Okay? So that's what the slope represents. All right, the second thing it wants us to interpret is the y-intercept, and the y-intercept is this value right here, the constant. So the y-intercept is 0.253. And so what does the y-intercept represent? The y-intercept would be the cost of the hamburger with no meat. And so therefore the y-intercept is approximately $0.23 or 23 cents. Could be reasonable. I'm not really sure how much a hamburger costs without the hamburger, so but it could be a reasonable y-intercept for this case. And then the last part of part A I already talked about. Does the y-intercept make sense in this situation? It's about approximately 25 cents for everything but the hamburger, so the bun, whatever else comes on it. So that could be reasonable. I'm not really 100% sure how much that would cost, but let's move on to part B. What is the residual for the hamburger with the 3-ounce patty? What does it mean in context? So remember, the residual is the actual minus the predicted. So the residual is the actual minus the predicted. Okay? So a 3-ounce patty, so let's go and find the 3-ounce patty, find how much it cost. So this is the actual, okay? And then the predicted, we're going to have to plug in to the line of best fit, or the LSRL. So y is equal to 0.253 plus 0.735. And we're going to plug in 3 ounces of meat, and then we'll calculate that value and see what the cost of the predicted hamburger would be with 3 ounces. Y is equal to 2.458. And since that is dealing with cost, that would be approximately rounded 2.46. So what we now need to find the actual, which was $3.20, minus the predicted, which would be $2.46. And so if we take $3.20 and subtract $2.46, we get 0.74. So the residual is, and this is the the y value, so we're talking about money, so 0.74. And then it asks, what does it mean in context? Well, with a residual of $0.74, it means the 3-ounce hamburger cost 74 cents more than predicted in the least square regression model. All right, part C. Charlie's friend says that in his hometown he can buy a 1-pound hamburger for $14.70. Would this be a reasonable price in Charlie's town? Show how you know. So we're going to use the least square regression line model to predict what a 1-pound hamburger would be. But remember, 1 pound, since we're measuring in ounces, we need to convert that to ounces. So 1 pound is 16 ounces. So we're going to use our line, y equals 0.253 plus 0.735, and we're going to plug in 16 ounces and see what the predicted cost would be. And we get a cost of $12, rounded to the nearest cent would be $12.01. So the predicted model is saying that a 16-ounce, this is part C, a 16-ounce hamburger would cost predicted around $12. And Charlie's friend is saying that he's buying it for $14.70. So from our model, it seems that would this be a reasonable price in Charlie's town? It looks like it'd be a little bit overpriced by approximately a little bit more than $2. So at this point, I think we have answered all of the questions. Once again, all the information was given to us, the scatter plot, the line of best fit, the least squared regression line. We were just answering the questions based off of that information. Question 36. An item currently costs $20 is increasing in cost by 5% per year. We're going to answer 3 questions. What is the multiplier? What will the item cost 5 years from now? And write an equation to find the cost in years. So we have the multiplier. Now, we got a couple of things here, though. The item cost currently, so that's currently cost $20. That's that initial value. So that's where we're starting. It's increasing at a rate of 5% per year. Now, 5% is 5 out of 100, which is 0.05. Now, it's increasing at a rate of 5%. So our multiplier is not 5%, because if you think about it, you have your initial $20. If you only take 5% of $20, that's just what the increase is. We want to know what the cost is every single year. So if we want the multiplier, we want to take the 100% where the cost is currently and add the 5% to that. So that's 105%, which as a decimal, which is what we'll be using, is 1.05. So 1.05 would actually be our multiplier, so we can figure out that cost each time by multiplying by 1.05 instead of having to add it back on to each of those. Question B, what will the item cost 5 years from now? So technically we could actually do C first and write the equation, but let's kind of go in the order it is. We have a couple of things that we need to indicate. What is our independent variable and what is our dependent? Well, the time is our independent, so I'm just going to say T, and actually I'll go back and say let T. So we're going to let T equal the time, and the time for this is in years. Okay, and then our other variable we can indicate as the cost or the total, something like that. So we'll let C equal and I'm going to write it as total cost of the item. And the total cost, this is going to be in dollars. So there's that. So if we look at this, one way we could do this is as a kind of a table here. And at time 0, the initial cost was $20. And then at time 1, our multiplier is 1.05. So if we take 20 times 1.05, that'll give us the cost after 1 year, which will then be $21. And then after 2 years, we do the same thing. We multiply by 1.05, and we get the cost to be $22.05. So we could keep doing this because we're only going out to 5 years, so it's not terrible. But we're going to find a shorter way to do this when we go to do part C. And maybe you've already done that, which is fine also. You don't have to do it this way. But then if we take the $22.05 and multiply 1.05, I'm going to round this to the nearest cent because that's how our money works. So $23.15. And then we'll do it again. Do it 2 more times here. So $23.15 times 1.05 is going to be $24. And rounded once again would be 31 cents. And we'll do it one more time here. So $24.31 times 1.05, we get a total of $25.53 if we round. So what will the item cost 5 years from now? The item will cost $25.53 5 years from now. When we look at part C, and this is the one that I said you actually could do C before B and probably would have helped you out a little bit and not showing all that work, but it says write an equation to find the cost in years. So we're going to write this instead of, I guess we can write it as C since it's our dependent. So C is equal to, and what's our initial value? Well, our initial value is the $20. And remember, since we're multiplying right here, this represents a geometric sequence. All right, or we could look at this as being exponential. So we know our initial is 20. We need to times it by the multiplier, which is 1.05, and then raise it to the t power. You could also write it as a function. So if you wanted to do f of t is equal to 20 times 1.05 raised to the t, that would be fine as well. So either one of those would work. Now, if you think back to question B, if we would have used this, and we said, well, what is f of 5? And we plug this into our calculator, because I want to show you the difference here. So if we plug this into our calculator and we take 1.05 raised to the 5th power, you actually get 25.5, well, I guess on this one it's okay, 525, which will still round to 25.53. So it did give you the same answer. Sometimes it wouldn't, because over here on this side, we were rounding, and that could cause some inaccuracies where on C we didn't do any rounding. But in this case, it actually did work both ways where we got the same answer. So $25.53 for that. But on part C, it's really just asking for the equation. Question 37, solve each system of equation using the method of your choice. So we're going back to solving systems. On part A, it looks like it is set up for elimination, but could definitely be used in substitution. My only issue here is my x's and y's are not lined up. So I'm going to rewrite the first equation where it's x plus y is equal to -2. And then that way I can just leave this second equation alone. Now, nothing eliminates. I am going to use elimination. But nothing eliminates the way it is. So I'm going to take my top equation, and I'm going to eliminate the y by multiplying by 3. So my new equation will be 3x plus 3y equals -6. And then my second equation will stay the same because I'll be able to eliminate my y values. So I'll get 8x is equal to 16 divided by 8. X is equal to 2. And then you can plug that back into the first equation. So if x is 2, we subtract 2 to both sides, and we get y is equal to -4. So the solution, remember, we want the solution, which is the intersection of the two lines, is 2, -4. And we could check that if we wanted to by plugging things back in. Part B, this one, your first equation is x equals 3. So you already know what x is. So we're going to use substitution on this one. And just take that x value and plug it right in where the 7 times x, so we'll do 7 times 3. And then we can go ahead and solve. So this one actually works out pretty nicely for substitution. We get 21. We subtract 21 from both sides. -2y equals 3 divided by -2. And y is equal to -3/2. We already have the value for x, so we don't have to find that. We already know that. So it's 3, -3/2. And once again, we could plug those back in. Actually, we really just need to plug them into the second one to see whether that solution is correct. Question 38, if f of x equals 1 over x plus 2, find each of the following values. So we'll go back to first start with part A here, f of negative 3. So f of negative 3, wherever there's an x, you plug in negative 3, and then you evaluate it. So f of negative 3 is equal to 1 over negative 1, which is negative 1. So when you input negative 3, you get an output of negative 1. Part B, f of negative 1.5. So this is equal to 1 divided by negative 1.5 plus 2. And so that would be 1 divided by negative 1.5 plus 2 is 0.5 or 1/2. And you can either do this in your calculator if you want, or if you understand, hopefully you realize that when you divide by a number, you are multiplying by its reciprocal. So you could actually even show your work, multiply top and bottom by 2, so that gives you 2 divided by 1, which is just 2. So f of negative 1.5 is 2. All right, part C, f of negative 2. And once again, we're just plugging the value in for x. So negative 2 plus 2 is 1 divided by 0. And what's 1 divided by 0? If you're not sure, plug it in your calculator. Remember, you cannot take a number and divide it amongst no one. So therefore, this is undefined. So you cannot divide by 0. You can take 0 divided by a number, but not a number divided by 0. And then the last one, D actually says x. Find x if f of x equals 5. So this is saying that the output is 5, and now you have to find the input. So you might be able to potentially plug in some numbers and guess, but I'm going to solve it algebraically. So that means I'm going to multiply to get rid of the denominator, both sides by x plus 2. So it'll be 5 times, but it's times the quantity of x plus 2. And then this just cancels on this side, so it's just left with 1. I'm going to use the distributive property. Subtract the 10, divide by 5, and get x equals negative 9/5. So on the last one, you're actually finding the input when you're given the output, whereas the first three, you were given the input and you were trying to find the output. Question 39. Determine the slope and intercepts for the line, 2x plus 3y equals 6, and then draw a graph. I forgot to add graphs on this question, but we'll make it work. So find the slope and the y-intercepts. Well, if you're trying to find the slope and the intercepts, you could do a couple different things. If I want to find the slope, typically I want to write it in slope-intercept form. If you want to find the intercepts, slope-intercept form works well for y-intercept, but not x-intercept. So if you're trying to find intercepts, if you're trying to find the x-intercept, then that's when y is 0. And when you're trying to find the y-intercept, that is when x is 0. And then your slope, you want to probably use y equals mx plus b. But if you find your intercepts, you can actually just do the change of y or the change of x. So there's a lot of different ways that you can do this. I'm going to go with the way that I think most students would probably approach this. 2x plus 3y equals 6. We want to solve for y. And as I said, this is not the only way to do this. So if you did it a little different, that's perfectly fine. Just check your answers. So if I divide by 3, that's y is equal to negative 2/3 x plus 2. So now that I have it in this form, there's two pieces of information I know. I know what the slope is. So the slope is equal to negative 2/3. I know what the y-intercept is. That's at 0, 2. The one thing I don't know from this equation is what the x-intercept is. So if I want to find the x-intercept, I can plug 0 in for y. Now I can do that in this equation right here, or I can do it in this one. So it's a little bit easier in the top one, so that's the one I'm going to use, one that's in called what we call standard form. So 2x plus 3 times 0, because I'm going to plug 0 in for y, and then I'm going to solve for x. So 3 times 0 is 0, so I get 2x is equal to 6 divided by 2, and I get 6 divided by 2 is 3. So my x-intercept is at 3, 0. And then to go ahead and graph it, you guys should be using graph paper, and I should have put one on here, but I forgot. So If I have a graph, if I want to graph it, and I have 2 points, then that's enough to graph the line. So I'm going to graph the y-intercept at 0, 2, and I'm going to graph the x-intercept at 3, 0. So here's 3, 0, and here is 0, 2. 2 points determine a line. So mine's going to be a sketch here. Yours should be definitely more accurate looking than that. But that would be the equation of your line 2x plus 3y equals 6. Or you could have used slope-intercept form, y equals negative 2/3 x plus 2. So then you would have went down 2 and to the right 3. So that's still got the same points though. Question 40. The graph below represents the temperature of a cup of hot water that is left on a kitchen table. Question A. What does the horizontal line, which is called an asymptote, represent? So it's talking about that horizontal dotted line there. So what does that represent? As you can see, the graph and the temperature of the water decreases as you go down the line in terms of the time. And then eventually something happens where it just seems to kind of almost stop. And that line would represent what? Well, whatever that, it's looks like it's sitting on a kitchen table. So the temperature is not going to continue to decrease. It's basically going to decrease until it hits that room temperature, and then at that point it's going to stop decreasing. So that's what that horizontal line represents. It kind of represents the room temperature, and the hot water will approach room temperature but will never cool more than that. Question B. How would the graph be different if the cup of water was left outside during winter instead? So the temperature is going to continue to decrease, but the horizontal line of the asymptote would be a little bit lower, but still parallel to the x-axis, because at some point the temperature is going to stop going down. Now, if the temperature outside was below 0, the asymptote would be below the x-axis. So it doesn't have to stay above the x-axis, but it could go below if the temperature was below 0 as well. But you're still going to have that horizontal line or horizontal asymptote that represents the point at which the hot water stops going down, whether it's room temperature, outside temperature, whatever it is.